Okay, hello, welcome back to your Bridging Mathematics. Okay, so we are done with your Module 1, Module 2, and Module 3, which consist your um, algebra and then trigonometry. Okay, so we will proceed with your Unit 4, which is uh, tackling about your analytic geometry. So we will now proceed with your analytic geometry. So again, as I recall in your 4 years of high school, you had this basic analytic geometry wherein at least you had an idea about the equations of lines, circles, and then slopes, and so on and so forth. However, we will be still discussing all of those before we will proceed with the conics and the second degree curves. Okay, so this is your unit 1, first unit under your analytic geometry, which will be tackling about the rectangular coordinates. Okay, so we will be discussing again, or we will be recalling the coordinate system, the rectangular and the polar, which is supposedly discussed in your high school. Okay, so rectangular coordinates. So in this unit, we will be expecting for you to know how to plot points using rectangular coordinates, to determine the distance between 2 points, or we call that one the length of a line segment, and then to determine the midpoint of a line segment. And at the same time, again, as I've said a while ago, is to determine the slope, or we call that one the inclination of a line. Okay, so rectangular coordinates. If we say rectangular coordinates, this is locating points. Okay, locating points, wherein we will be using the distance of that point to the x and y axis that we know. Okay, and that is written into this form. Okay, the coordinate of x, or the distance from the distance horizontally, or that is reckoned from the y-axis, and then the y coordinate is the distance vertically, which is reckoned from the x-axis. And then of course the intersection of these two axes, major axis, is what we call as the point of origin, which is located at point 0, 0. So again, there are number scaling here, wherein going to in your x-axis, going to the right from the point of origin is positive number, and then to the left is a negative number, and then in your y coordinate or y-axis, going up is positive and down is negative. Okay, so that is the very important basic concept of your rectangular coordinate. You should know your sign conventions. Okay, so again, the x in there, in our figure, in the figure that I drew here, let's say we will consider this point here, and that is described by its coordinate x sub n, y sub n. So let's just say x sub n, y sub n, so that will be general. It could be any points. So that x sub n, again, as I was saying a while ago, that is the horizontal distance from the point of origin, or that is your x coordinate. So if you try to look here, that is just the distance of this point to your point of origin, which is actually your y-axis. So that is the horizontal distance. So that is your first number in your coordinate system, or your coordinate. And then yn, y sub n, is the vertical, or that is the y coordinate, or that is the vertical distance of the point from the point of origin. Okay, so this is your y sub n. So again, it is this term rectangular coordinate is again literal, because as you can see here, if we are trying to locate a point, it will now be forming a rectangle with respect to your origin. So let's say I will consider here a point somewhere here, let's say at point 1, 1. Then that will be actually creating again a rectangle with respect to your origin. Okay, so we call this one the rectangular coordinates. So we have here your quadrant 1 and quadrant 2 and 3 and 4. Okay, so these are actually just the divisions of your locations. It is divided because of this x-axis and y-axis. Therefore, you have here your quadrants 1, 2, 3, and 4. Okay, so basing on the sign conventions that we have, if you have there a point at quadrant 1, okay, what we expect here is a positive distance x, since that is located on the right side of the origin. And then, of course, in your y is also positive, since that is located on the upper part of your y-axis. Okay, so if you will now consider here any point, as long as you are referring to any point here within your quadrant 1, then you will expect that always your x and y axis will be positive. So this is just again just a summary of these points within your quadrant. But eventually, if you will now get use of plotting points in your rectangular coordinates, then you can actually forget about this, since this is the basics of this. Okay, so if you will now try to consider any point here in your quadrant 2, you will expect that since that is now on the left side, that will always be a negative x coordinate but positive y coordinate. And so with your quadrant 3, that will now be a negative x and then a negative y. And so with your quadrant 4, it will now be going back to positive x but still negative y. Okay, so this is your rectangular coordinates, your quadrant 1 to quadrant 4. Okay, so we have here now the important, again, before we will start dealing with the equations of your curves and lines, it is important for you to know how to determine distance between points in your rectangular coordinates. Okay, so let's say I will consider here 2 points. That first point here, let's say that is your P sub 1, it means that is your first point, or P1. Then, okay, we do not know this one. This is in general, so I will say that has a coordinate of x1 and y1. And you have here another point, P2 or P sub 2. It has a different coordinate, of course. Since that is a different point, then that is a different coordinate. So let's say that is x sub 2 and y sub 2, so that it will now be stating that is coordinate of P sub 2. Okay, so the subscript again will just stand the name of the point. Okay, so d there is the distance. Okay, that is what we are trying to find here. The distance between these 2 points P sub 1 and P sub 2. And actually, if you will try to relate this one into what we call as the line segment, okay, actually if you will connect 2 points in using a straight line, that is what we call a line segment. We call it a line segment because it is a line that is terminated, or it is a line with a specific length. Because if you will just be saying line, generally line, if you will now consider a line which is straight, that will be continuous all throughout. It will not stop, or it will not terminate. But if we say line segment, there is a certain length for that line. Okay, so if you will consider the distance of that 2 points, or the straight distance between these 2 points, that is the same as the length of your line segment if I will connect that one by straight line. Okay, so again, that dash there on top of your P sub 1, P sub 2 means line segment. That is the meaning of your bar on top. Okay, so that means from point 1 to point 2, line segment from point 1 to point 2. Okay, and then if you will try to analyze this one, all we need to do here is break down and create our right triangle. That's why we discuss first your trigonometry, because that is important before we proceed here in your analytic geometry. So how are we going to solve that distance? That distance, again, as I'm saying, is just the length of your line segment. So how are we going to solve that one? Given only your coordinates. Of course, that is only your coordinates. That is what you will be having, since that is what you will be using to plot the points. So how are we going now to solve that distance? D is actually, we can consider here a right triangle. Since we are dealing here with vertical distances and then horizontal distances, your coordinates are again just distances, vertical or horizontal. So if we will consider there your lines, then that could just be straight line vertical and straight line horizontal. So if I will try to drop here an imaginary line, that is actually from the x-axis going to that point 2 is actually the y coordinate of your point 2. And again, from this point here, point 2, going to that y-axis, that is the x coordinate or the x distance. Therefore, if I will now try to create this right triangle here, imaginary right triangle, so that we can deal with that distance, then all I need to do actually is to find the sides of your right triangle by how? Subtracting your coordinates of the 2 points. So if you'll try to look here, the coordinate or the distance of that second point to your x-axis is your y2, and the distance of your first point, which is y1, is this distance from the x-axis also. So that distance here is the same as the distance there. So the total distance going to point 2, I will subtract that distance going to point 1 is the delta y. We call that one the delta y, or that means change in x. I mean delta, oh, sorry, that is delta y, so that is the change in y, or we call that one the difference in y. This is important also. You need to know this one because you will soon use this one in your calculus subject. What is the meaning of delta? That is the change or the difference of whatever variable it is paired with. Okay, so delta y again there is just the change or the difference of the y coordinates of your higher point and then lower point. So y2 minus y1. So that is the length of this leg of the right triangle, and then the base of that is the same, since again x coordinate are just coming from your y-axis. Then the farthest there is the x2 or the x sub 2, or that is the x coordinate of your point 2, and the shorter there is the x coordinate of your point 1. So the total length to your second point minus the total length from your first point is actually this delta x here, which is again x2 minus x1. So we have again these coordinates, then we can actually subtract those coordinates to get this delta y and delta x, and that will now serve as the side of our right triangle, and then by merely Pythagorean theorem from your trigonometry, given these two legs of your right triangle, this length actually, or the line segment, will just be your hypotenuse. So that is now just Pythagorean theorem. Okay, so the hypotenuse squared is equal to the square of the both legs. So I need that one, so get the square root of both sides. Okay, therefore you will end up there with the distance or the length of your line segment is the square root of the square of the delta x and delta y. Okay, do not forget delta x and delta y is x2 minus x1 and then y2 minus y1. However, it's okay, you can interchange y1 and y2 and then x1 and x2 as long as, okay, if you consider the first point as your subtrahend, then that will also be your subtrahend in your y. But if you consider that your second point is the subtrahend in x, let's say I will interchange this one x1 minus x2, then that should be the same in your y. That should be y1 minus y2 also. Okay, you should align the subtraction of your coordinates. Or you can just say 0.1 minus 0.2. Therefore, x1 minus x2, y1 minus y2. So it's up to you. So now, let's try to have an example for this, determining the distance between these 2 points, or between 2 points, or actually in our figure here, in the problem, it says there that determine the distance of the lines connecting points. Okay, we are given here 3 points, points A, B, and C, and you are given the coordinates. So all you need to do is first plot that one in your rectangular coordinate. So first, point A is located at -2, +3. So of course again always x before y. So x is -2, I will go there, -2, and then y is 3. So I will go up, since that is positive, I will go up, therefore that is your point A. And then we have here a second point B, which is located at -1, -1. So first again x is -1, therefore that is this one, -1, and then a -1y will go down, so that will go down there. Therefore that is your point B, which is -1, -1. And then the third point is your point C, which is located at coordinates 2, 1. So x is 2, y is 1. So +2, so to the right, and then +1 going up. So that is your point C. Okay, so this problem is trying to determine the distances of the lines if we will connect these 3 points. So if we will try to connect this point A to point B, that is this green line here, that is your line segment AB. And then connect your B to C, that is your yellow here, or the orange here, that is your line segment BC. And then connect your A to C, that is your line segment AC, the red line. Okay, so that is what we are trying to solve the distances. So again, just go back there to your formula for distance between 2 points. Change in x squared, the square root of the change of x squared plus the change of y squared. That is the distance between the 2 points, or the length of your line segment. Okay, so let's start with your AB. AB. So again, as I've said a while ago, if you choose your A to be the subtrahend, then the x of this b minus the x of a, and then the y of that b minus the y of a. But if you choose that your b is your subtrahend, then all you need to do is reverse. But for me, let's say I will, since I wrote that one a to b, therefore let's say I will subtract your a. That is, let's say my first point, then b is my second point. So second point minus first point. So let's start with your delta x, that is x coordinate of b minus x coordinate of a. So -1 minus negative. Okay, you need to consider the sign. So again, since I am basing on your performance on your activities, that is your common mistake because you forgot to use your grouping sign. That's why you ended up with wrong answers. Even if you will just change one sign of your equation, that will change, or that will give you a very, very different answer. That's why it is important always for you to make use of your grouping signs. Especially this one, that is a negative which is subtracted. So you need to enclose that one by a grouping sign or parenthesis. Because later on, if you will not do that, then you might forget that that is just a positive. Okay, so now again, let's go back. Delta x is, let's say, x of b minus x of a, and then y of b, that is your delta y now, y of b minus y of a. So -1 minus +3. Okay, if you will now try to evaluate this one, you will end up with the square root of 17, or in decimal that is 4.12. We do not have given units on our x and y axis. It is not given if that is centimeter or meter or whatsoever. So let's just say that is units, okay, to be general. Okay, therefore the length of your line connecting, or line segment connecting A to B, is square root of 17, the exact value, or in decimal that is approximately 4.12 units. Actually, you can verify that one if you will draw this one in a scaled manner. You can actually verify that one using a ruler if you are using a ruler to plot your coordinates. Okay, so how about your BC, line segment BC from B to C? If I will connect that one, okay, that is the distance that we are trying to solve, or that is the length of your line segment BC. So the same, I will consider my C as the second point, B as my first point. So I will follow the arrangement of my naming, B to C. So always C minus B. So x first, okay, 2 minus -1. So you have here delta x as 2 minus -1, and then in your y is 1 minus -1. Okay, so you will end up with the square root of 13, or that is again approximately 3.61 units. And then if you will try to solve now your final A to C, so I named that one in a manner A to C. So C is my second point, A is my first point. So C minus A. So you have here the x first, okay, 2 minus -2, okay, 2 minus -2. Do not forget always that is squared. And then y is 1 minus 3. And then evaluate that one, that will be 2 square root of 5, or approximately 4.47 units. So again, by looking at the values of our three line segments, the longest is your AC and the shortest is your BC. So you can actually check that one by actually observing your drawing. If you draw that one correctly or scaled, if you draw it scaled, then you can actually check that one by observation. So maybe we can say yes, that is correct, because your AC is longer than both of them. Okay, and then your BC seems like the shortest of all of these three sides. Okay, therefore that is the length, or the distance between the 2 points that we are considering. Okay, it is also important here for us to let's say we will consider here a line segment. Again, let's say P1, P2, that is a line segment. What if you want to get the middle of that? Okay, you want to locate the middle of that, we call that one the midpoint. Okay, we call that one the midpoint, or the center of your line segment. So how are we going to evaluate that one? How are we going to find the center of that line segment? Is actually making a use of your coordinates. So how will we find the x coordinate and y coordinate? Actually, if you will try to look here, that's why I drew it this way, so that you can actually analyze. If you will try to look here, this is your y2, that is your y1, and that should be the middle y sub m. So the question, what is the relationship of this y sub m, or the middle y, with your 2y? is actually, if you try to get the average of these two, then that will give us this middle. Okay, so again, that is just average. So if you're referring to y coordinate, that is just the middle or the midpoint. Y is just the average of your y coordinates of the 2 points that we are considering. Same as your x. Okay, same as your x. This is your x sub 1, x sub 2, and you want to get the middle of that. So again, all you need to do is get the average of that. So x sub 1, x sub 2. So by the way, how do we get the average? All you need to do is add and then divide by how many numbers that. Since we are referring to x1, x2 only, then divide that 1 by 2. So add your x1, x2 and divide it by 2. That is your average, or we call that one the x coordinate of our midpoint. And then with your y, y1 plus y2 divided by 2 again, and that will be your y coordinate of our midpoint. Or you can actually factor out your 1/2. Therefore 1/2 times y1 plus y2, or 1/2 times x1 plus x2. Okay, so that is how you will find your midpoint. So again, let's try to go back to the same problem. We will just continue so that we will not be drawing a lot of figures here. So let's say I want to get the midpoint of each of the line segments. So we are referring here to the line segment, the line connecting AB, BC, and AC. All we need to do is find the middle of those. So let's start with your line AB. Find first the midpoint of line AB or line segment AB. So again, go back there. That is just the average of x and then average of y. So I will get the average of this x. If we are referring to average, always consider also the signs of that. Okay, we need to consider the sign convention of that. So it says there all we need to do is add. So carry the sign. So -2 plus -1, you will end up here actually with -3. But do not forget, we are getting the average, so we will multiply that one by 1/2 or divide it by 2. So you will end up here with -3/2, or in decimal that is -1.5. How about the y coordinate of that? 3 plus -1, if you will add that one, they will end up as +2. They will subtract. So that's how important you will be considering the signs. So 3 plus -1, you will end up there with +2, but multiply that one by 1/2 or divide it by 2, you will still end up with 1. That is 2 over 2, or 1, +1. So your coordinate now is -3/2, or that is -1.5 and 1. So x coordinate is -3/2 and y is 1. So that is our midpoint for line AB. So if you'll try to check that one, actually you can say yes, that is correct, because by merely looking, by merely observing your drawing, it seems like the middle of that is located at somewhere between -1, -2 of your x, and then somewhere there in your 1 in your y. Okay, so you can verify that one always by your figure. And then line BC, so the same, get the average BC. So B and C, get the average of -1 and 2. So get the average of -1 and 2. -1 plus 2 will be actually +1, and then multiply that one by 1/2, it will still be 1/2. And then in your y coordinate, -1 and 1, you will add that one, that will actually cancel, it will be 0. So even if you will multiply it by 1/2, it will still be 0. So your coordinate for the midpoint of BC is at 1/2, 0. Okay, 1/2, 0, +1/2 and 0. And it seems like again we are correct. Somewhere there, it is exactly at the x-axis, and it is located somewhere between 0 to 1. So your x is 1/2, and then y is 0 because there is no going up or going down. And then line C, AC, the same. Okay, get the average of +2, -2, that will cancel, so it will be 0. And then average of 1 and 3, you will add that one, 4 divided by 2 or multiply by 1/2 is 2. So you will end up here with the midpoint of that to be at 0, 2. Okay, 0, 2. Which is, again, you can verify that one, 0 in your x because that coincides with your y-axis, and then 2 because that passes your y-axis at 2. Okay, so that is your midpoint of line segments, average of the coordinates. Okay, so this one again is very important. This is again a recall. If ever you still can recall your slope or inclination in your high school, or this will be An introduction to those who forgot. Okay. So slope, again, if you say slope or inclination, that is the slope, or that is the steepness. If you say steepness, how sharp the line is inclined. Okay, that is the meaning of your slope or inclination. This is very, very important because you will not just be needing this one in your mathematics. However, this is very, very applicable in your actual life situations or on actual problems. Okay, slope. For example, there is, let's say, if you are civil engineering, then you will be dealing with highways, and it is important always that you know how to determine slope of highways, or in the first place, you should know what is the slope. Okay, so how are we going to get the slope of a line? Okay, so again, if you will try to look at my figure here, if you will try to consider again still your line segment P1, P2. Okay, let's say that is the line that we are referring to, and you want to get the slope of that or the steepness of that line. Then actually we can name that one as m. That is the general or the common, okay, common variable for slope, m. And then theta is, let's say theta there is the angle from horizontal. Okay, so what is slope? Slope is actually there your m. So what is m? M is actually just the ratio of your delta y and delta x. Okay, that is just delta y over delta x, change of y over change of x, or that is just your rise in your right triangle and then run in your right triangle, the height and the pace. Or if you want to make use of the angle from the horizontal, let's say that is your theta there, isn't it? Making use of your right triangle again. If that is your theta, I want to relate that one with your delta y, delta x. That delta y is the opposite and that delta x is the adjacent. So what is adjacent, opposite of adjacent? That is tangent. So tangent theta is delta y, delta x. Therefore, there are two ways to get your slope. If you are given the coordinates or distances of your right triangle, then all you need to do is divide the rise run. Okay, this is also a common term for slope, rise over run. Okay, vertical distance, horizontal distance. Okay, delta y, delta x. And then if you want to make use of the angle, let's say you are not given the coordinates, but you are given the inclination or the angle of that line from the horizontal, which is theta, then that is the same as just tangent theta. Okay, so there are two ways again, using the angle or using the distances. However, it is important here in your slope that you should know what is the meaning of a positive and a negative slope. Okay, so if you say positive slope, that is actually just a line that is rising or rises from left to right. It is going up. Okay, a line that is going up. If you will follow that from left going to right, that is a positive slope. And then a negative slope is the opposite. If that will now falls from left to right, okay, that is a negative slope. Okay, so how do we end up with positive and negative? By the way, how do we end up with a positive and negative? Let's say I will start from P1. Okay, I will start from P1 here. For me to go to your P2, okay, vertically we will go up. Okay, we will go up, so that is a positive value. We will still consider the directions of your x and y. Going up is positive, going to the right is positive, going down and left is negative. Okay, so from point 1, okay, so from point 1 we will go up. That is your delta y, which is positive, whatever that value is. And then we are still not on point 2, so we will go to the right. So go up is positive, going to the right is positive. So positive divided by positive will always be positive. Okay, your slope is positive. That explains that is going up. Or let's say you want to consider this point on top as your first point. That will still be the same. Okay, let's say from point 2 going to point 1, I will go down. That is a negative delta y. But I will go to the left, which is a negative delta x. So negative delta y and negative delta x, negative and negative cancels, it will still be a positive slope. So it doesn't matter how you will solve this one, how will you subtract your delta x and delta y, even if you will end up with positive, negative, as long as you will be still considering the same points, then that will end up with the correct sign of your slope. So again, let's say from point 1, go up is positive, go to right is positive, so positive. From point 2, go down is negative, but go left is negative, therefore dividing 2 negative will still be a positive. Okay? If you will try to do different from that, okay, let's say I will consider 2 points here. Okay, I will explain that one now here on the board since so that we will not ruin our figure there. So let's say so that we will have a line. The first point is higher than the second point. So if you try to connect this one, that is your delta y and delta x. So let's say this is point P1, point P2. So how do you end up negative here? Because again, by merely looking at that, it is going down, so that should be a negative slope. So a slope here is, okay, from point 1 going down is a negative number, whatever that number here. And then we will go to the point 2 going to the right, so a positive number. So negative and a positive will end up negative number. So your slope is still negative. Even if you will start from P2, okay? P2. For me to go to P2, going up is positive, whatever that number here. And then going up is positive, but going to your P1 is going left, so negative number. So again, different signs will still end up negative, whatever that value is. Therefore, always going down is negative and then going up is positive. Okay? So please do not forget about that. That is very, very important for slopes. Okay, so again, let's continue the problem that we had before. What if, let's say, you are tasked to get the slopes of this line segment that we solved a while ago, the line segment AB, BC, and AC. So let's say, okay, for line AB, get the slope of that. You will expect that that should be negative since as you can see that is going down. Okay, so again, delta y, delta x. Do not forget about that. Delta y, delta x. Y over x, or vertical over horizontal. That's why in other book they call this one as rise over run. Okay, rise over run. Okay, so delta y. So again, if we say delta y or delta x, always consider the same point as your basis. So if I will say from A going to B, then always B minus A. Okay. So let's say, okay, again, B minus A. So in your y, delta y is negative 1 minus 3. Okay, minus positive 3. In your delta x, negative 1 minus negative 2. So again, grouping sign, that is important. You will end up here with positive, with negative 4, because that will end up negative 4. That will end up negative 4. Okay. Okay, so slope again. Let's try to determine the slope. We are done a while ago with your line AB, so that the slope of that, let's say that is M1. Okay, again, I will try to name that one M1, M2, M3, so that they will be different. Okay, so slope of your AB is your M1, slope of BC is M2, and then AC is M3. So we are done with your M1. So how about M2, the slope of your BC? So the same, delta y over delta x. By the way, you might be asking there, where are we going to make use of that tangent theta? Okay, in the first place, what is given to us is the coordinate. These are distances. You are not given any angle of that. So we cannot make use of your tangent theta. Okay. However, there will be some cases again that you're given is the angle. So you can make use of tangent. So again, always that is from the horizontal, because maybe you might be confused later on. What is given is your angle from vertical, but you are using the angle, then you are using that one directly. You should get first the angle from the horizontal before you will make use of tangent. Because if you try to again make use of the angle here, let's say that is the angle from the vertical. Then if you are relating your delta y over delta x is not a tangent. That is the inverse, which is cotangent. So if this is your angle, you will be using cotangent. However, in calculator, you do not have directly a cotangent. Since again, in your trigonometry, if you try to recall your trigonometry, cotangent is just the reverse of your, or the inverse of your tangent. So it will always be better if you will make use of the angle from horizontal, because that will be tangent, which is found in your calculator. Okay, again, so making use of delta y delta x, because that is what we can have all only. We do not have there any angle. So for M2, delta y delta x of your BC. Okay, so change in y, 1 minus negative 1. Okay, 2 minus negative 1. Okay, and then you will simplify this one. This will end up plus. So 1 plus 1 is 2, and that will become plus. 2 plus 1 is 3. So 2 over 3, that is 2/3, or 0.7. Is that 0.75? No, 0.67. The slope is 2/3 or 0.67. But always, it is always better, again, as I've said before, it is always better if you can make use of the full value. Okay, so that is positive 2/3. Okay, by the way, positive. Why? Because that is going up. So even if you will try to reverse the delta y delta x, let's say subtract c from b, that will still be the same here. If you can try that one. You will end up a negative on top, negative below. This will still cancel. That will still be positive 2/3. Okay, so how about your angle, or the slope from AC of AC? So again, delta y delta x. So delta y first, c minus a, always c minus a. So 1 minus 3, and then 2 minus negative 2. You will end up here with negative 2 on top and positive 4 below. That will end up negative 1/2. Again, negative because that is going down. Okay, by the way, in your slope, if you will try to analyze this one, okay, tangent theta. Okay, so what is tangent theta? If you will calculate, if you will try to put a smaller angle here in your theta and compare that one with a bigger angle of theta or value of theta, you will expect there the higher the value of theta, the higher the value of this tangent theta. So what does that mean? The higher the value of theta, or the sharper the line is inclined, the higher the value of the slope. So if you try to look here, okay, this is steeper than this one. Okay, so AB is steeper than BC, but of course they have different signs, because going down and going up. But the point here, if you will try to look at the values, AB is steeper than BC. So you will expect that the slope of BC is smaller than AB. So if you try to go there, the slope of AB is 4, but negative, of course. But the slope of BC is only 2/3, or that is just only 0.67. Okay, if you try to look here also in your AC, compare that AC with your AB. AC is a little bit smoother than AB. So again, 4 is bigger than 1/2. So if you'll try to look at AC and BC, you cannot actually determine which one is steeper, if that is BC or that is AC. But by merely looking at the values, 2/3 is bigger than 1/2, or 0.67 is bigger than 0.5. So therefore, your line BC is steeper than your AC. Okay, so that is the importance of your slope. Okay, that is the importance of our slope. Okay, so that is your rectangular coordinates. We are using here distances, vertical distance and horizontal, or that is the x coordinate and y coordinate. These coordinates are again distances which are reckoned from your point of origin, or the intersection of the x and y axis. Now, this is another type of coordinate. We call this one the polar. Okay, polar coordinate. You might already again encounter this one during your high school, but if not, then we will discuss it here. Okay, so polar coordinate, that is almost the same, only that in your rectangular, you are defining, or you are trying to locate a point by x and y coordinate. in your polar, we will make use, first before we will discuss that, in this unit 2, polar coordinate, you will expect to have these outcomes also. Plot points using polar coordinates and then convert, this one, convert rectangular coordinate to polar coordinate and vice versa. If you say vice versa, baliktaran or the other way. So if you have a rectangular coordinate, you can actually convert that one into a polar. Or if you have a polar, you can actually convert that back to rectangular. Okay. And then of course, if we will have the polar coordinate, we can also make use of that to get a distance between 2 points. Okay. So the same, only that we have different type of coordinates. So what is polar coordinates? So if rectangular is distances vertical and horizontal, polar actually is now using angle and what we call the radius. Okay, so location of a point is defined by its distance from the point of origin. Okay, so wala siyang sinabi. There is no word there describing vertical or horizontal. It says there only a distance from point of origin. So that means it could be inclined. Okay, it could be inclined. So let's say I will consider here this point here on top. This distance that we are referring to is this broken line, the green broken line here. So that is your distance, and actually we call that one the radius. Okay, we call that one the radius, and its polar angle measured from positive x. So now you will define by a distance from the origin and an angle. So that is how we will locate the points in your polar coordinates. In your rectangular coordinates, we define or we locate a point by distance vertical and distance horizontal, or the coordinate x and y coordinates. But in polar, we will locate a point by its distance directly to the point of origin and the angle, or we call that one the polar angle, which is actually measured from positive x. Okay, so we say still you have there your of course axis, but there is no more x and y axis because what you only have there a vertical and horizontal. There is no x and y because we are not using rectangular coordinates. Okay, so again, that is how we will locate. So if you can locate that one by distance, horizontal and vertical, we can also locate that one into this manner: direct distance from your origin and the angle of that imaginary line connecting your origin to the point. Okay, which is the angle is always reckoned, or it is always measured from the positive horizontal or positive x. You are connecting it with your rectangular. So R there is the radius. So let's say that is the point, then that is the radius. If this is the point, then that is the radius. And then we have here positive and negative. If we say positive, okay, but first before we will discuss that, what is theta? Again, polar, that is the angle reckoned or measured from positive x. So the pair of that radius is the angle. Okay, just like writing your x and y coordinate, but this time a distance and an angle. So distance first before the angle. So distance, whatever that distance is, and the angle, measure that one coming from the positive horizontal. Okay, so whatever that angle is, that is the second coordinate there. So radius and angle. That is how we will define using polar. So how about here, second point? Okay, so radius, and then again, where is the angle? You might be confused. Where is the angle? But again, it is important that it says there measured from positive x. Okay, or reckoned from positive x. So always the angle is coming from your positive vertical, horizontal. So that is this broken line which is red. That is our theta. Let's say theta n Rn. Okay. So how about this sign convention, the positive negative? So if you have there a negative or positive distance, what is the explanation of that? So if you say positive radius, that is a distance, the point is located towards the terminal. Where is the, if you say terminal, if you will go back again in your discussion of your trigonometry, you have what we call, in measuring angle, you have a terminal. So this is the angle, isn't it? From x going to that. So this is the terminal of the angle. So if that is a positive distance, then that will, from the origin, that will go towards the terminal. Okay, whatever that radius is. How about if that is negative? That will be opposite direction of the terminal side. So if this is your, let's say that is 30 degrees, positive radius is within this one, but a negative radius will be opposite. So I will explain again here in our board. Okay, so let's say this is again your horizontal and vertical. There is no x and y since this is not a rectangular coordinate. So let's say this is the terminal. You want to measure, you are given a theta which is 30 degrees. Okay, let's say that is 30 degrees. So the point will lie somewhere there in this line, since that is the 30 degrees. So when do we have a positive? If the point is within your terminal itself. If this is the point, then you will end up there with radius which is positive. But if your radius is negative, that is the opposite on this side. This is the terminal, this is the opposite of your terminal. So if that is, let's say the point is there, then the radius that you're referring to is negative. Okay? Positive or negative. So let's say, okay, this is now the angle. Let's say this is the angle. So this should be your terminal. So if that is a positive, then the point will be located somewhere there. That is a positive R. If that is negative, that is the opposite of the terminal. So somewhere there is your point. Okay? So you should know the directions of your positive and negative radius. How about this one? Okay, if you will go there, you have there a positive and negative polar. Positive and negative polar angle, or the positive or negative angle. What does that mean? A positive is always measured counterclockwise. Okay, always measured counterclockwise. A negative is measured counterclockwise. The other way. Positive is counterclockwise, negative is clockwise. Okay, so this angle here that I draw on the board, these are positive angle. Why? It is counterclockwise. If you say counterclockwise, it is against the flow of your clock. Okay, so that is positive. However, let's say you want to define, or you want to define this line here using a clockwise angle, so that should be a negative. That is a negative angle. Still coming from the positive horizontal or positive x. You want to get the angle going clockwise, then that is a negative angle. But if you want to get an angle, let's say you want to get the angle of this one line using a positive, then that should be a counterclockwise. This is the angle counterclockwise, so that you will consider a positive. But if you will define that by a negative, then that is this clockwise angle going to this line that we are referring to. Okay, so again, you need to know your sign conventions. In your rectangular coordinate, we have sign convention: a positive, negative, up and right is positive, down and left is negative. However, in polar, that is the meaning of your positive and negative radius and positive negative angles. Okay, so again, I gave you here what do we call this one? Just a summarize of whatever this positive negative is. Okay, so let's say you have the positive radius. You will fall in your quadrant 1. The point will be in quadrant 1 if you have the positive radius and your angle is 0 to 90. Okay, your angle is 0 to 90, isn't it? If you will go back to your trigonometry, this is 0 degrees. That is 90 degrees, that is 180 degrees, this is 270, and then going back to its origin is 360. Isn't it? One complete rotation is 360 degrees. So your point will be there on the first quadrant if you have a positive distance and an angle which is 0 to 90. So that will fall in your quadrant 1. How about negative? Can we still have a point which is negative in your quadrant 1? Yes, but your angle will be different. Let's say your angle or your terminal will be here in your, this is 180, isn't it? 180 to 270. So your terminal is somewhere here, as I'm explaining a while ago. Let's say that is your terminal from 180 to 270, but your radius is negative. Therefore, you will fall, your point will be still on quadrant 1. Okay? So again, that is just the opposite because of the negative radius. So that will be the same. So you can look at this one. Okay, this is just the summarize. Again, let's say quadrant 4. When do we have a quadrant 4? Point on the quadrant 4. Okay, if you have an angle of 270 to 360 and a positive radius, of course. Okay, you will have your point here. And at the same time, you can also have that one if your angle is 90 to 180, but your radius is negative, so it will be directed to your fourth quadrant, the opposite of your second quadrant. Okay, so that is your polar coordinate. Let's try to have, before we will go there, let's try to discuss how to convert your rectangular to polar coordinate or the other way. Okay, so let's try to, what do we call this one? Let's try to understand that one. Okay, so let's say you are given a rectangular coordinate and you want to put that one in a polar coordinate. So for example here, this is your point. You are given your xn and yn. Isn't it? Xn and yn. That could be your xn or this could be xn, since that is just a rectangle. If that is your yn, then this could be your yn. That's why again we call this one rectangular coordinates. Your vertical is your y, your horizontal is x from the origin. Okay, how do we get that r and that theta that we are referring to in your polar coordinates? This rn and theta n. Actually, that is just again a right triangle. You'll try to connect that radius with this x and y, then you will end up with a right triangle. Okay, so that is just a right triangle. So if you want to get your rn given your yn and xn, Pythagorean theorem, isn't it? Pythagorean theorem, square of Rn or the hypotenuse is equal to a square of Xn and the square of Yn. You want to get Rn, get the square root of both sides, then that is just a Pythagorean theorem. How about if you want to get the angle? Okay, this is a confusion, guys. Okay, so please be careful with this. If you are using this one, okay, how do we get, by the way, that angle here? Let's say that is the angle from the horizontal, because actually that is what we need, angle from horizontal. So if I were you, I will not consider this right triangle here. I will consider this right triangle because the same, the xn and yn will still be same. So let's say that is my theta. If you have a point in quadrant 1, the theta, whatever theta that you will be solving, is equal actually to the theta n. Okay, do not be confused with this. Whatever theta that you will be solving, that will always be an angle from horizontal. So I will explain that one later on. So we will go to this red color on this other side. But first in this one, okay, solve for theta. How do we solve the theta? Again, in the first place, what do we know is this yn and xn. So we will relate that y and then this xn is using tangent again, opposite, adjacent. So tangent theta is yn over xn. This one. What I need is to get the theta. So get the arctangent. Get the arctangent of that. Get the arctangent of whatever that value is. You will have your theta. But that is first theta. That is not automatically xn because it depends on the point or in the quadrant that where we are in. So in your quadrant 1, as I'm saying a while ago, your theta is the same as your x sub n or your coordinate theta or polar angle. Okay, automatically, because again that angle here is coming from the same angle coming from your positive horizontal. But that's why I gave here another example. Let's say I will consider this point here. That is your y and that is your x. Again, the same, getting that radius there is by Pythagorean theorem. Let's say I will consider this right triangle here, so that we are connected with the horizontal. Then, how do I get the theta? Isn't it that if you will try to go back here, theta n is always from the positive x going to the terminal or to the line that we are, or to the radius. Isn't it? So that should be our theta n. But in this one, if you will try to solve using arctangent, what can we get? Getting the arctangent is this angle here. So let's say that is theta. That is your theta here. What you will get is the theta here, not the entire angle from the positive x. So I put here a note that theta n, or your polar coordinate or polar angle, is to be determined using whatever theta that we will be solving in your tangent. Okay, and it depends on whatever quadrant that point is located. So look at here. If your point is here and you know your theta, you can solve that one. The theta is solvable by your tangent here. How do you find your theta sub n? So that is just simple. That is just simple, guys. That is this small angle here, that is theta. All I need to do to get that theta sub n is add 180. Why? Because from this one, that is 90 and that is 180. I will add the theta going to this radius. So that is how we will end up with your theta n. That's why I did not write here exactly as that, because that should be general. How about if you have your point here? Let's say somewhere there, point. You have here your point. Okay, I will explain that also on the board again. Okay, let's say you have a point in your quadrant 2. So in the first place, let's say what you are given is, that is your y sub n and this is your x sub n. This is the point. This is your y sub n. If that is xn, this is also xn, that is also y sub n. But the point there is, using xn and yn, the angle from horizontal that we can get is this one, that is your theta. But the theta sub n, or the polar angle, is from the positive. So that is this angle. So that is your theta sub n. So how do you find your theta sub n? Knowing your theta, that is just, this is a straight line, isn't it? 180 degrees minus whatever theta that you will be solving, that is the theta sub n. That's why I did not write it there as is, because that depends on the quadrant. Okay, let's say you have here your point. So again, where is the theta that you can be solving? This is the theta that you will be solving. But that is not your theta sub n. Your theta sub n, again, if you are considering a positive, guys, if you are considering a positive angle, then that will be turning. But if that is a negative, then that will go this way. However, since again we are used with positive angle, so that is your theta sub n. So how do we get the theta sub n knowing this theta here? That is a total complete rotation if you will go back to itself. So that is a 360 degrees. Subtract that theta here that we solve, then that is your theta sub n. Okay? So again, that is how you will find your polar angle, or the angle coordinate of your point in your polar coordinates. Radius is just as simple as Pythagorean theorem, but again, you need to be careful with your polar angle, because again, the angle that you will be solving is not your theta sub n right away. So you need to know where the point is. Is that in your quadrant 1, 2, 3, or 4? Okay, so how do you know that again? If you are given your rectangular coordinate, then you can decide that one, isn't it? That's why I gave you here this one. If you are given the coordinates, let's say you are given a positive x, positive y, then that is at quadrant 1. If you are given a negative x and negative y, that is at quadrant 3. Or by merely looking at your x and y axis, you can say that where that point is located. Okay, you can say where that point is located. Okay, so that is how we will convert from rectangular to polar. How about if you are given a polar but you want to get a rectangular? The same. All you need to do is plot that one, construct your right triangle, use Pythagorean theorem, and use your tangent. So, I mean the angle and your sides. However, we will not be using here Pythagorean theorem because in the first place, let's say, okay, let's try to reverse the process. You are given your radius and the angle. Okay, so again, for us to break this right triangle into its leg and then the base, you should know the angle. But again, what will be given is theta sub n. So, babaliktarin lang natin. If you are given a theta sub n, then solve for theta. So, that is what we will be using in your solution. Okay. So, let's say in this triangle here, you are given your Rn, R sub n, and you are given your theta sub n. In the first place, get first your theta. Okay, it depends where that quadrant is. So if you have already your theta, then all you need to do is break this down into right triangle and you will get your y sub n, x sub n. So you know your angle and you know your hypotenuse. So relating that one with the opposite, which is your opposite, which is your y sub n, that will be opposite hypotenuse is, okay, let's start with your x sub n. If you're given r sub n and then the angle there, you want to get your x sub n, this is adjacent, that is hypotenuse, so you should be using cosine. So cosine theta is your adjacent x sub n and then hypotenuse r sub n. But what we need there is the x sub n. So cross multiply r sub n, then your formula is just r times cosine the angle. Radius times cosine the angle. That is your x coordinate in your rectangular. How about your y? This will now opposite, that is hypotenuse, so instead of cosine we will be using sine. So y sub n over rn, cross multiply rn, your y coordinate is r sine theta. Okay, even if your point is here. Okay, again the only difference is that you're given theta sub n, subtract 180 so that you will get your theta. So in the first place you need to know your theta. So get your theta and then again make use of, you want to get x sub n, that is still adjacent of the angle. This is still radius, which is the hypotenuse, so that will still be x n over rn. Cross multiply is still r cos theta. Y is still r sine theta. Okay, so that is how we will convert rectangular to polar coordinates. Okay, how about getting a distance between 2 points using your polar coordinates? Okay, how about that? This is now using your trigonometry. So consider here 2 points. Let's say that is p sub 1, p sub 2. Or you can say this is p sub 1, p sub 2. It doesn't matter actually. Okay, so all you need to do there is plot. This is your radius 1. Let's say that is p1, therefore this is your radius 1. And the angle theta 1 there is, or sub n, your n is 1 since that is 0.1. This is 2, so that your n is 2 here. Okay, so that you will not be confused. That is the use of your subscript. So in your point 1, that is your radius 1 and the angle theta 1 from your positive x still. Okay, always. In your point 2, that is your radius 2 and that is your angle. That is the red one here. That is your theta 2. Again, coming still from positive x. If you try to look at this, the distance or this line segment here, or that distance between them, is actually, if you'll try to connect that one with your radius, that is actually a triangle. You know these sides, isn't it? These are the radius. You know that one since that is given. That is your polar coordinates. And actually making use of this polar angle, you can get the angle between these two radius. Any radius, you can get the angle given your polar angles. Look at this. If that is theta 1, and going to that red is theta 2. If I will subtract theta 1 from theta 2, that is actually the angle between your two radius. Here. Isn't it? That's why theta 2 minus theta 1. So you have this side, you have that side, you have the angle between. Then, what can you recall from trigonometry is cosine law. Okay? Cosine law po lang yan. So again, ano yung sabihin ng cosine law? The unknown side squared is equal to the square of the two given side minus 2 times these two sides, cosine of the angle between them, or the angle opposite the unknown. Okay, so that is our cosine law. Isn't it? This R1 and R2 are the given sides, minus, of course, 2 times that R1, R2. Cosine, what is the angle between them? Again, how do we get that angle between them is this theta 2 here, the bigger angle minus that shorter or smaller angle, they will get the angle between. So theta 2 minus theta 1. That is in our orientation. But let's say this is your point 1, that is your point 2, then that will interchange theta 1 minus theta 2. So it depends. So always plot and then figure out. Okay. So that is the angle here, whatever the difference here. Then again, you want to get the distance or the length of your line segment P1, P2. Then get the square root of both sides for you to get your D. So if I will do that, substitute the values of R1, R2, and then the theta and the theta there, the 2 theta, then you will end up with a value of your distance. Okay. Let's have now an example. Okay, so this is a combination. We will be having an example of converting from one coordinate to another, and at the same time we will be solving the distance between them. Okay, so actually this is the same example, however I just made it as 2-point only. If we'll try to go here, I considered your point A and point C, but I interchanged the naming. So this 2, negative 2, 3, and 2, 1, that is what I use. Okay, so that we will have a way of checking. Our answer here should be the same as our answer a while ago. So this is negative 2, 3, that is given. Okay, this is forget first about this. That is what we solve. We will be solving this one. In the first place, what is given is let's say that is point A. I interchanged the name. This is a while ago point C, but I will put that right now as point A. Let's say this is A, this is B. A is located at 2, 1, okay, and then B is your negative 2, 3. So that is the given in the first place. So we will get that distance between them, or this line segment AB, using its polar coordinate. A while ago we get that one by rectangular coordinate, but this time let's try to use your polar coordinate. That should be the same. Okay. So in the first place, I want to get first the polar coordinate. So these are actually these values here, but I will discuss how that is done. So first, how do you convert this 2, 1 into that polar coordinate? So again, create your right triangle. This is your R. That theta A again is, okay, we are fortunate that is just automatically our theta. So if I will create my right triangle, then this is my 2, isn't it? That is the X, and here is your 1, which is your Y. So again, that is just your coordinate. So you want to get your theta A and you want to get your RA. So again, how do we get that radius? Pythagorean theorem. Okay, that is just Pythagorean theorem. How do you get your theta? First, we need to get your theta, but at the same time, that is automatically your theta sub A in this case. So we do not need to be solving your theta and then finding theta sub A, because that is the same. So get your theta here is using tangent. Tangent theta A is, what is this? That is your Y, which is 1 over 2. So tangent theta A is 1 over 2. Now get the arctangents. Arctangent of 1 over 2 is your theta A. Again, that is just your formula here. Get the arctangent. Transfer your tangent. So that is your 1, 2. Okay, that is your rise. That is your run. That is your del. That is your Y. That is your X. 1 over 2. Okay, so you will end up here with theta A, which is 26.57 degrees. Okay, yes, maybe. That looks like 27 degrees. Okay, so again, our theta is right away our theta sub A, because that is correct from positive to the line. Okay, how about your point B? Convert that negative 2, 3 into a polar coordinate. Okay, by the way, get your radius here first in your RA. Okay, Pythagorean theorem, square root of 2 squared plus 1 squared, you will end up with square root of 5. I will make use of the total square root of 5. I will not be putting it in the decimal, so that we can compare the values later on. How about your point B? You are given negative 2, 3, negative 2, 3. Okay, again, create your right triangle. In the first place, this is my theta. This is the theta of my right triangle. But the theta b there that we need in your polar is should always be coming from the positive horizontal. So that is this solid line or the solid arc. That is your theta sub b, and the line connecting the origin to that point is your RB. So what is this angle that we will be solving? You can say that is theta, or let me just put that as theta sub b prime. Okay, lagyan ko lang siya ng prime para hindi siya automatic na theta sub b kasi hindi siya automatic. So, okay, what we will be solving using arctangent, okay? Arctangent, okay, by the way, tangent is the opposite, which is 3. And then your adjacent is your horizontal, which is 2. Okay, by the way, do not make use of the negative. Negative is the direction in your rectangular. So, we will not be considering negative here if you will be solving your radius and your theta. We will not consider the signs. Only the lengths, okay? So that is your y, that is your x, 2 and 3. So tangent is 3 over 2. I will get the arctangent of that, that is your theta. Again, that is not automatically theta sub b because this is your theta sub b. That is our theta sub b prime. I put that one, I named that one as theta sub b prime. So, okay, I will do that. That will be 56.31 degrees. Now, you want to get your theta sub b since that is actually what we need. Isn't it? That is what we need. So, again, that is a straight line. So, 180 degrees. Subtract your theta sub b prime from 180 degrees. You will end up with 126.69, which is true because that is more than 90. Okay, so that is our theta sub b. And get your r sub b Pythagorean theorem, that is square root of 13. Now, that is not the answer here because what we are trying to find is the distance. These are your coordinates. That is this one. Okay. Your B is at... Oh, sorry. This should be interchanged. Sorry. Okay. Again, sorry about that. I just interchanged. Actually, it will not affect the answer because that is just the drawing. Okay, so again, that is how we ended up with this polar coordinate here. Your point B is located at your radius, square root of 13, and your angle, polar angle, which is 123.69 degrees. And then your point A is located at radius, square root of 5, and the polar angle, which is 26.57. So again, the point there is, our target here is to get your line segment AB, or the distance between A and B. Okay, so how will I do that again? That is your cosine law. All you need to do is apply your cosine law. Square root of the square of the first side, this is the given. That is your r sub a given. Okay, isn't it? That is already there. We solved that one. Plus the square of your second side, which is r sub b. You already have that. It's the square root of 13. Minus 2 times r sub a, r sub b, cosine the angle between them. So the angle between them is this one. The angle between this red and the green line. How do we get that one is, okay, what is theta b? That is from your positive going to that red line. What is theta a? That is from the positive to the green line. So I will subtract both of them, theta a from theta b, to get the angle between these two lines. So that is our angle here. 123, the bigger angle, 123.69 minus the smaller angle, which is 26.57. Calculate that one. I am 100% sure that is 4.47. And isn't it, as I have said a while ago, that is the 2 point, that this example is the same as the 2 point a while ago. So we solved the distance of this one, isn't it, a while ago? We solved that one using your rectangular coordinate. So let's try to compare. 4.47, that is this line. Go back to the answer a while ago. Actually, that is your AC because I interchanged the name. Look at the length of AC, 4.47. Okay. So now you can see that even if you are using two different coordinate system, okay, you can relate both these two coordinates, your rectangular and polar, and you will still end up with the same distances. Okay, so that's it, rectangular and polar coordinates. So if you have a question, again, just comment below the video, or we will discuss that one on the next live meeting. So thank you very much for watching.